Hello and welcome back to ReddyControls. In our last video, we discussed how to implement logic for alarms, and we also learned about the power of using sequencer-based logic to help us build built-in diagnostics in the PLC logic. Today we're going to take that a step further by adding cycle time. Cycle time is a critical metrics in any automation system. By accurately measuring the time it takes for each cycle or operation, we can gain valuable insights into efficiency of our process and identify potential bottlenecks. So our current code, as we look at the code right now, the current code is based off sequence we looked at last week. The video is going to show up on the top left side. As we remember, if we recollect it, we have a total of 9 steps, and every time the machine is in each step for about 2 minutes or 3 minutes, we raised an alarm and we used that alarm and displayed it on the HMI. Now, using the same concept, we're going to build logic for cycle time. So I will go ahead and create a new routine, add new routine, and we'll name it underscore 40 underscore cycle time, and we'll just say this, and we'll put it in the conveyor program, say okay, and we'll go ahead to the main routine and copy paste, control C, control V. We will add a jump to subroutine so that the machine can scan it, PLCs can scan and execute that. We'll go ahead and finalize all edits in the program. Now we go to cycle time logic. In here we will build the logic. Before we build the logic, we need to create some tags. So we'll go ahead and right click, new tag, create cycle time. So we just call it cycle underscore timers, and these are timers each step. As usual from last time, and timers, they are defined in the conveyor belt global. They're not program. If you want them to be program specific, then we make them controller conveyor program, but right now we'll just make a global or controller scope tags, and we say create, fail to create, new tag data type could not be found. It's not timers, it's time. And we create 100, say okay, create, we insert equal to okay. And whenever at our logic, we are saying in auto, if it's in 0 set, so 10 is the cycle. So we'll go ahead and build for everything. So, and the step number is called as execute. So I can just copy paste this instruction, copy, go back to number 40 and control V. I can remove this, delete. So if you are in step 0, insert a retentive timer on. Okay, retentive timer that accumulates time whenever it's enabled, unlike a standard accumulated value, even if it's temporarily disabled. This feature makes RTO perfect for our needs, as it ensures accurate time tracking for each state in our sequence. So we'll go ahead and use cycle timers, and we'll use 0 for step 0. We'll use about 43,200 thousand. So we'll give about 12 hours of cycle time, and we go ahead and assemble that. Yes, okay. So we just copy paste this one and copy paste it for each step. Is equal to 10 here to which you hit tab, we change, enter, tab here, that's 30, that to 30 there, 60, 70, 80. In our logic, what is the max step is 90. It's 80, and so that's all. So we can go ahead and all of them, finalize all edits. Yes, once we finalize, as you can see, we are in step B here. We started timing, the RTO started counting, and it counts seconds, how many seconds is the machine is in step 80, right? The machine is still at 80, so we'll try to sequence the machine, build all of this. But one of the main thing we need to do when we need to figure out a way to reset all these timers when we want, right? So as we look at the ladder at step 0 to start at timer, if we look here, we are also, the bad box is, there is a reset, and we use the reset to move the sequence to step 0. When we hit the reset button, so whenever we completed step is when we want to reset all the timers, because that's the end of the step. Yeah, to 0, and a bad box is present, 0 into that time. So we want to add say insert when sequencer step is, and we oops, I made a mistake here. This it's in a lot back here. Control V that, and we will timer 90. When sequence, I can do Control C. We just put all of them. We can start at 0, 40. Step. We can figure out a different way to reset. We could either reset all the times once you go into, once you're not in auto, once you are in, we can just do this, add it, go back. If once that cycle is over, and put like once we are in manual, we reset all the timers and restart everything. But depending on what the application is, you could, but the main thing is we want to know what is the total cycle time for that cycle. Do a simple compute instruction, or we could do we can do a compute. So go ahead and insert tag is total time, cycle time, create. Here all we do is we can select this new tag or host tag, and we have all our cycle timers. So we'll take cycle timers dot accumulator, and we just keep adding all this time. Or you could do it but this is a lot easy, so we can cover the constructions are easy. You just need to walk through this tiny space here. Window, unfortunately, Rockwell had this one. 3, 6, right? Okay, my bad. And then go all the way to the front, and then start changing them to 50, 20. That's correct, and it will. So one thing that's going to happen in manual, all the timers are going to reset, and then our total for that cycle will be 0. So in order to prevent that happening, we will take this. So but one thing we need to make sure is we have to Created a small logic here where after we compute everything, once the sequencer step is in step 0, we want to copy the total cycle time from here into the temporary buffer and do an open. Once that copy complete is high, we use a one shot and then reset all the timers. Okay, so to make it easier, what we will do here is making this cancel this one. Instead of calling this as total cycle, just call this a total cycle time. Apply, okay, and we just move kill time in, and we call this as local. Okay. File handling, and we'll talk in detail about how to log the last 10 cycles and create an average cycle time for the last 10 cycles. For now, city's sake, we'll just use total cycle time. We'll just take the previous time and put it as a total cycle time. So that's it. So we'll go ahead and test and see how it works. So I will go ahead and put the logic in a separate with the close all this, close that. And as we about the watch window in the previous videos, we can reuse the watch window here. That makes it easier to watch all. There are two. We can add that to the watch window, and then to let's go previous. Okay, so we can see, make it big, close that gap. Okay, so as you can see of the current cycle time, just for clarity, we just called it previous. Let's rename that. Yeah, that's a previous cycle time, or we could say, you could see both. So now the sequencer will index it to all the steps. We will and then select a switch there in step, select a switch 4, and to go to step 30. We are in step 30 now, and then once in step 30 we want to be waiting on that one. Once we are in step 40, we are waiting on go away, and so now we are in step 60, and to sequence it to, it's a good box, so we will use the switch 3 right in step 70 now, and so we moved back to 10, and you could see our previous cycle time is logged into the total cycle time. So that's how you use RTOs. Calculating. All what we did is we added, as a conclusion, what we did was we added retentive timers, and we calculated total cycle time, and we moved it in cycle time. And this reset logic is based on whatever logic is better for your application. There's always a flavor to that, but that's how you use sequencer based programming and creating cycle time logic. In the next video, we'll talk about creating a log and make a average cycle time and idle time, how to capture how many minutes per day is the machine being, and how do we use all of this to create a percentage on this machine, equipment efficiency calculation. That's it in this video. To monitor the process efficiency, but also provides critical data for making informed decisions. If you found this video helpful, don't forget to like and subscribe and hit the notification bell so you don't miss future tutorials. See you in the next video. Thank you.